Okay, so now we're going to go into experimental designs, and we're going to talk about a few different types of designs that are considered to be within that pure experimental model where we can establish causation. We're going to start with the most basic version of things, an independent groups design, and then move through some variations. So let's go ahead and get started. So within experimental designs, we're going to first talk about independent group designs. So you can think of all of these as independent group designs, and we're going to go ahead and distinguish additional types of designs that are not independent in just a little bit. There are 4 different types of experimental designs I want us to go through that are the most basic model of experimental designs. The first is called post-test only control group design. That's a lingering cough from my bronchitis. I'm much better. Don't worry about it. It's not COVID. All right, so let's go ahead and go through this particular setup here. Now, these symbols represent different things. So the R lets us know that it's been randomized. And then we have X's and O's. You can think of the X as some sort of manipulation and the O as an observation. So in this particular design, we have 2 different groups. One has a manipulation followed by an observation, and the second does not have the manipulation and is followed by an observation. You can think of the first row as the group of people that's assigned the experimental condition, and the second row is the group of people who's been assigned to the control condition. And of course, this is randomly assigned between the 2 conditions. We have that R there to let us know. So those 2 groups have been randomly assigned. So group 1 has received the manipulation, then observation, and then group 2 has no manipulation, then observation. And the observation can be some sort of measure of your dependent variable, like performance or ability. So for example, you could have people in condition 1 undergo a meditation activity and then see how their stress levels are during the observation phase. And people in the second group do not go through the meditation activity, but you also give them the same measure of stress. And you could compare the stress of group 1 to the stress of group 2. This is the most basic experimental design. So some advantages of this. It's relatively easy to implement compared to other types of experimental designs. It's kind of your basic model. We're going to go through different models where you test ahead of time. So you do a pretest. Sometimes you can't pretest for various reasons, which we'll go through. But in that particular case, you can't do a pretest each and every time, and this particular model is then preferable. One of the disadvantages, because you don't have that pretest, you can't actually measure how people change over time, which can sometimes be useful and interesting. But keep in mind that we have randomly assigned them, so we're going to assume that they start off roughly evenly to one another. So the randomization here serves as almost a substitute pretest, if that makes sense. So we assume groups start off the same, but randomization certainly helps us with that assumption. So it's not necessarily, we're not making stuff up. All right. Now, this is a bit of a walk down memory lane, everybody. I want us to think a little bit about what type of test we would use to compare group 1 versus group 2 on their stress. So if we were comparing O1, or not O1, but O from group 1 with O from group 2, we would be comparing 2 separate groups of people to one another. Now, because we're using 2 separate groups of people, and there are just 2 groups, we would be using an independent samples t-test to test the difference between group 1 and group 2 on their level of stress. Hopefully, you remember independent samples t-test from statistics. I just wanted to bring that up again in terms of the type of test that you'd be using. As a quick reminder, I'm going to be asking you to come up with an analysis plan as part of your phase 4, but that's a little bit later on this semester, so we'll revisit that later. And once again, an independent samples t-test compares the difference between 2 separate groups. All right, let's move on to the second design, which is the pretest post-test control group design. You might notice that the thing we have now is O1 and O2. So we have a pretest and then an intervention of some kind, and then a post-test for group 1. And for group 2, we have an observation at time 1 and an observation at time 2, but there's no intervention. So for example, you might give a reading ability test to students and then have them undergo an intervention for reading where they get special training, or where they don't do that intervention at all in the control group. And then you test their reading ability again, and that would be the second observation. And you compare the people who underwent the intervention with the control condition that didn't undergo the intervention. And once again, there's that R indicating that the two groups have been randomly assigned. On a side note, I would recommend that you do your MyOpen Math on this because it works through all these different designs and gives lots of examples. So I think that would be a really great practice for you to take a look at and to test yourself on. When it comes to advantages of the pretest and post-test, sometimes it's very useful to be able to compare the pre to post to see about change over time. Another thing that you can do, and this is especially what happens if you are looking at change that is a little bit more longitudinal, is you can actually, because you've measured at the start, explore why people might have dropped out of the study. Sometimes if it's a longitudinal study, for example, where you're measuring students' reading ability over the course of an entire semester, sometimes students leave the program. And so you can actually compare the students who left the program with the students who stayed in the program in terms of their pretest scores to see if they differ in fundamental ways, which can sometimes be useful. And if you don't do that with a pretest, as you couldn't do for the first example, then you don't have that data. You can actually measure O1 versus O1 in your experimental versus control groups to actually ensure that your groups have started off evenly. When it comes to disadvantages, when you give someone a pretest, that can sometimes tip them off as to the study's purpose. So they become just a little bit more aware of what it is that you're studying and what it is that you're interested in. And sometimes those expectancies can change how they might respond to your experimental intervention in ways that you might not be able to anticipate. So giving them that pretest can sometimes prime the pump, as it were, and lead to different responses than if the pretest wasn't there, which can be a challenge. The pretest itself can sometimes provide a confound, where the presence of the pretest could lead to changes that you can't anticipate or otherwise plan for. There's also the notion of testing effects. So testing effects would be the fact that they took the test twice. The fact that you have the control group lets you measure just general testing effects so that you can actually explore how the control group has improved over time and use that to measure how much testing has impacted your study. But there's something known as a testing interaction, where sometimes taking the pretest and then engaging in the intervention leads to some sort of different result compared to people who did not take the pretest. And that interaction doesn't necessarily pop up when you're just looking at the control condition. It's the experimental condition that can sometimes be a little funky when you combine the pretest with the experimental intervention. So the testing effects can sometimes appear challenging to measure and can be there. This can also be a little bit more time consuming and difficult to implement, giving multiple measures. It doubles the amount of data you're working with. And once again, if you have to do a pre and a post, it can just take up a little bit more time, energy, and expense. All right, so this is coming back to statistical tests. Let's go ahead and take a look at this particular design and think a little bit more about the different things that we can test here that are expanding on what we could test before. So let's say, for example, we wanted to make sure that the two groups started off equivalent to one another. So we wanted to test O1 for group 1 versus O1 for group 2. If we wanted to do that, we would be looking at the differences between two independent groups. So you can see how that would sound a little bit familiar to what we did before. Similarly, what we did before was we were looking at the observation at the end of the study. If you wanted to compare O2 for group 1 and O2 for group 2 to see if they differed because of the experimental intervention, then that would be comparing two independent groups to one another. You would run an independent samples t-test for both of these tests. Let's say that you wanted to compare O1 to O2. In this particular case, you'd be looking at change over time. As a reminder, this is something that would use a dependent sample t-test. Do you remember dependent sample t-tests from statistics? This is where you have the same group of people and you're looking at how they change over time. So if you were comparing O1 to O2, that would use a dependent sample t-test, which would test the difference between two scores from the same sample over time. So that's just kind of a brief reminder about independent and dependent sample t-tests, just to kind of refresh yourself a little and connect it with the study's design. All right, so this particular type of design is the Solomon 4. The Solomon 4 group design is a combination of the post-test only and the pre-test post-test design. You would only do a Solomon 4 if you wanted to specifically test to see if there was a pre-test effect that was weird or unusual that was affecting your data. So if you actually want to test for pre-test effects, you would run a Solomon 4. A Solomon 4 contains 4 conditions. In half of the conditions, you have a pre-test post-test design, and in the other half, you just have a post-test design. So this allows you to compare the top 2 groups with the bottom 2 groups to see if they are fundamentally different from one another. And if they are, it's because of the pretest. Hopefully that makes sense. So when you're doing a Solomon 4, this basically is the best of both worlds. You have all the advantages of 1 and 2, and you can actually measure the possible pretest confound. But the disadvantages of this is that, once again, sometimes you can't give a pretest. That's just kind of the way the cookie crumbles. Sometimes those pretests are not possible based on the way your study is set up. So you can't do either a pretest, post-test, or a Solomon 4. And with this particular study, if you have 4 conditions, you need twice the number of participants that you did for the other 2 studies in order to get the same statistical power. So it's a little bit more time-consuming, and it uses more resources. And once again, it's just more difficult to implement because you have more things to juggle. Let's go ahead and look at this and think a little bit more about the type of statistical test we would use. Once again, this is just intended to spark some memory from statistics and to have you thinking about how design is linked with statistical tests as a bit of a review in anticipation of having to do this exercise for phase 4. So if you were comparing O1 to O2, once again, that's change over time, so that's a dependent sample t-test. If you're comparing O2 to O2 to O2 to O2, that is actually comparing 4 groups now instead of just 2. And as a reminder, you can only do a t-test of independent means when you're dealing with 2 groups. So in this particular case, you would use a one-way ANOVA. A one-way ANOVA is the sort of test we would run when you have more than 2 groups and you want to compare them to one another. So you could do a one-way ANOVA to test the differences across all 4 of these. Now, we can get a little bit more complicated than that because of course we can, but I wanted to start with just a basic review of t-tests of independent means, t-tests of dependent means, and one-way ANOVAs just to kind of refresh you a little bit on that. And once again, a one-way ANOVA would let us test to see whether there's a difference among the groups. I wanted to go ahead and show you a circumstance where you might have multiple conditions. So for example, if you had reading intervention A, reading intervention B, and a control where there was no reading intervention, then you might use something like X1 to mark reading intervention A and X2 to mark reading intervention B. So you can have more than one condition that you are looking at where they differ among the conditions as well as a control. In this particular case, because you have 3 groups instead of 2, you would once again, guess what, have to use a one-way ANOVA in order to test those differences because we're dealing with more than 2 groups.